Okay, today I'm going to give you a quick lesson on how to open competition template in Vex Coding Studio to be loaded to your robot. It's important to understand when you're going to build a robot to compete competitively in a Vex competition that you always use a competition template. So first we're going to click on Vex Coding Studio. I like to enlarge the screen so you can see full use of it. We'll wait a moment while it loads. You have several options to go to. However, for this purpose of this video, we're going to go into Vex C++. ModKit is where you do a drag and drop type programming. Vex C++ is where you do it with a text coding. C++ Pro is more geared toward college-leveled students. Now you can go through and you can browse and look at different types of templates that are out there for you or that are already saved to your computer. Or you can look at example projects, the motion steps, how to use sensors, how to program a controller, information about your screen, and then right here is your competition template. Recent projects, if you've been working on something, they should fall here. As a rule of thumb for my class, we save everything to a thumb drive, just to back up and make sure that we have access to it in case the computers go down. So for competition templates, you just simply click on it, choose, and we are going to make sure we're using the C++, Vex C++, not C++ Pro. So click on Vex C++. You click on it twice, there's your competition template, and you hit open. Okay, once we're in the screen, you see here this is the competition template. As a force of habit, I always come over here and click competition project in addition to loading the template. We'll go ahead and save it as a test. Clear this out here. Test competition template and hit save. Now this is going to ask where you want to save your files. We'll go ahead and just save it to documents today. In the future we will make sure we do that to a thumb drive. So this is where you begin adding motors. On this screen you simply would drag the number of motors you have over. For this particular activity we'll do 2. You will have to have a controller. Okay. You would tell what port you're going to plug the motor in. You could change the name of it from just motor 1, motor 2, motor 3. You could be specific here, telling it that you're going to name it your drive motor, your claw motor, your tower motor, whichever you choose. Where that motor is going to be plugged in. For middle and high school students, we only use ports 1 through 10. We never use 11 through 20. That is for Vex U. Here, you will click on the settings. You can determine whether your motor is going to be a torque motor with a 36 to 1 ratio. Just a regular motor, which we normally use, is 18 to 1, or for a faster service speed, 6 to 1. You also have to pay attention to the direction your motor is spinning. If you need to reverse it, you can do so here. So you could do that for both motors. We're going to say we're going to reverse both of them, leave them at regular speed motor. We've added a controller. You can name the controller. For Vex purposes, you do have the ability to do a cotangent controller, which means you can have 2 people running your robot at once. And for that case, you would drag over 2. In this case, we would not. Just wanted to kind of show you what the template itself looks like. Where information goes, we're not going to write program today. We're just going to talk about the template itself. So when you open the text tab, robot is where it's talking about the motors, the actual subsystems. Here is where you're going to program those subsystems under text. So this is what makes the program work here. This is just a brief description letting you know that this one is going to be a Vex template. What that does is lets the competition field speak to the actual robot and ensures that the robot only functions at certain times during the tournament. So here is where it's programming in, hey, this is a Vex template, and this is what we're going to use it for. Under this section, it lets you know that you have pre-autonomous functions. These are functions that you might want to have done to the cortex prior to the competition starting. You have sensors that you want to clear and reset, anything like that. You would take care of this prior to writing your autonomous. And we go here between the brackets for your pre-autonomous functions. Scrolling down a little further, you have your autonomous task. It just gives you a brief description. This is just detailed descriptions and comments about what happens here. These are commands you can write for your robot to do during the 15-second of autonomous period, and those would have to go between these two brackets. It's important that you never add brackets unnecessarily or remove brackets unnecessarily. It causes the programming to not function correctly. Below that, you have your user task control. This is where we're going to program the robot to do certain things with the joystick, the buttons on the controller. And you have to put that in what's called a while loop. That while loop says that while you're doing one thing, other things do not happen. So for instance, if I wanted my controller to lift the claw when I push the right R1 button and then bring the claw down when I hit R2, you would say, if I'm doing this, if I'm pushing R1, the claw is going to go up. Or when I'm pushing R2, the claw is coming down. If I'm not doing either one of those, nothing happens. And you put that inside of a while loop, so it happens continuously as you're driving the robot. If you don't put it inside the while loop, it only happens one time and one time only. And those would be called inside the while loop would be your if else, or your else statements. Again, those go inside. Your main function is the user controls. These two brackets here and here. This set of brackets is the while loop, where you would insert that information. You'd put it before this sleep task. What this sleep task does is it tells the robot's cortex after you do something, it just continues that, but it gives it a small break. The 20 right here represents time that it would just give you a short pause so resources aren't wasted, and then it continually repeats that while loop process. And here is where it's going to call back all of the functions that you've put into your program. Okay, that is going to be your autonomous and your driver control tasks. And then here's your while loop here. This is just your closing while loop. And this says, hey, this is going to make sure we don't have it happening on an infinite loop. If we didn't have this here, the robot would try and do things constantly in your autonomous and your driver controls without shutting down. Nothing really changes in this lower portion of